Welcome back everyone to episode 5. We're heading into part 9 now. However, before we start that particular lesson, let's have a look at the scenario that I left you with at the end of the previous video. First of all, let's change that database. Fantastic, right. So, it was all about the purchasing manager who's after some data. And obviously the key things to take into account is she's looking to try and get the data from 2016, but she wants to compare it to the average in 2015. So there's a couple of where clauses that you need to get in the right place for this one. Step 1, of course, was to build up the query for the average out orders in 2015, and of course should only generate a single value. And then we had to build up the following columns here in a normal select statement. Next, we then needed to bring our query in from step 1 and build it into a where clause, making sure we filter the results from step 2 on that where clause in a little subquery. Step 4 was just to confirm the data by putting in the subquery as a column subselect. Right then, let's see how you went. Here's my answer there. So the first thing was to create this little query here, and we needed to get just the one value, which is the average ordered outers for 2015. Right, so then in order to be able to filter on the order date, we needed to get that from the purchase orders table, and of course the ordered outers come from the order lines table, so we needed to do some joining in there. Put in our filter, put in our function there, and of course as there's only one column there, there's no need to do any group by. So let's check out what we get when we run that off. We get 1815, so that's the value that we need to be working with. It's the average in 2015. Fantastic. So that was step 1 out the way. Next, we needed to build our normal query itself. So we're looking at purchase orders and purchase orders lines. Again, that'll bring us our purchase order ID and ordered outers. We also had our suppliers, which I put as P there, to get our supplier name. Stock items will give us our stock item name. So quite a few tables to join on, but pretty straightforward and simple joins there. All of them are joining on IDs, as you can see there. Pretty easy going. And again, because we're in a joining, it doesn't really matter what order you put your tables in this part here. And then step 3, we had to bring it in to a subquery in our where clause. Obviously, we needed to filter our results here by the order date being 2016. So if I simply comment those out and run this bit here, we know that this is all from 2016. So these ordered outers are from 2016 only because of our filter there. And of course, when we bring in with our subselect, we get the ordered outers there being restricted to 657 rows. If we just round it off without that subselect, we get 1060. So we know that our subselect here, ordered outers from our order lines table being greater than the one single value that we have here, we know it produces less rows, so we know that our filter's working properly there. And of course, as a quick check, uncomment that out, run the whole thing. There's our 657 rows and our average there. We can check throughout our whole list that our ordered outers are greater than our average. That one's close, but it's still greater than our average there. Same with that. So we're happy that our query works in its its entirety. How did you all go? If you followed the steps, I'm sure you went just fine. Right then, let's head on in to the episode. So, we're now moving on to common table expressions. First of all, let's change our database. So what are common table expressions? Well, CTEs are a newer version of the subselect that was introduced in later versions of SQL. And when we go through the examples themselves, you'll see why they were introduced. They're mainly there to help you out, help coders out with building some quite complex select statements involving subqueries all over the show. So let's have a look at the first example here. So this is effectively a subselect here. So we can run off this code quite happily there, and there you can see it produces a table of results. Happy days. So all we've done is simply put it within the open and close round brackets, and we've started off our query with the word with. So this tells the SQL Server compiler to expect a CTE to come in next. Now we have to give it a name, so we called it with invoices as, and that's the next keyword you need to put in, and then we simply paste in and build up our subquery itself. Now you can't just run this off on its own. What it needs is a select statement to follow it. Similar to any subqueries or subselects, they actually need to be within the select statement itself. And this is effectively the same thing, except we've basically just brought the whole subquery out of our select statement itself. As you can see, there's no subselects there, and we've built it up first, giving it a name, pretty much a pseudonym there, and we just bring that in to our join below there, as you can see. So that's all we've simply done, is taken the subselect out of the actual final select statement itself. We've built it up to begin with, given it a name, pseudonym, and then we've simply used that pseudonym within our select statement itself. And as mentioned, you need to have a select statement after you build your CTE, otherwise it will not work. Similarly, if we do not have the semicolon, because the CTEs are relatively new in SQL Server, if we try to run off our code, we'll get this error here. If this statement is a common table expression, which it is, the previous statement must be terminated with a semicolon. Now, when you're writing a lot of CTEs within other objects, etc., you might come across this error quite often. Just remember, all you need to do is put a semicolon at the end of the previous statement. Now, if we run it off, as you can see, it works fine. So all we've done here is we've calculated the sum, the order ID and the invoice ID, and we brought those in there purely and simply. Didn't really need the invoice ID there, as we're pulling the invoice ID, well, we're pulling it from that table anyway. So we've got the invoice ID, the sum, and of course joining on the order ID there. So within our CTE, the subselect portion, we still need to bring in any columns that we are going to join with. Pretty simple, pretty straightforward concept. Slightly easier to get your head around than building subselects within the select statement itself. All we're doing is effectively creating a temporary table on the fly with our CTE, and then bringing that table in there using our standard join methodology, making things a lot simpler to read, a lot easier to build your query itself. Another thing you need to know about CTEs is that while they are very good and easy to write, they tend to be very slow and consuming when dealing with a lot of rows. The rough rule of thumb is if you're building a CTE with 100,000 rows or less, then you should be fine. But at the end of the day, you should only be using CTEs or even subselects when you're dealing with smaller batches of data. There are other methods if you needed to build tables on the fly within your objects. There are other methods to make sure that your query runs efficiently when using a lot of rows, but generally when using just a few rows, like you see we've got 70,000 rows there, your CTE will be just fine in handling those. So as you can see below, we've then joined it onto our CTE of invoices onto our orders table, bringing in the invoice ID, invoice quantity and invoice amount. And there you have the results. So these are the results from the CTE, including the invoice ID, and these we just pulled from our orders table. So a bit of an easier method to write your subselects, and it's quite a preferred method. I like to use it myself. Keeps your final select code very neat and easy to follow. So let's have a look at another example. So this was one of the examples we had in part 8 at the beginning, where we first started looking at subselects within the joins itself. So all we need to do in order to turn this into a CTE is simply type the word with, and we're going to call it something meaningful, say orders. Now again, you can type what you want here, any form, any which way, uppercase, lowercase, doesn't matter, just as long as you refer to it within your select statement. And type the word as, and of course simply grab your code there. Now you don't put a semicolon or anything afterwards, because you, like I said before, you need to run it off with a select statement below. So there we have it, and that is simply how to bring your subselect out of the query and into your CTE. Now that we've got our pseudonym there, we simply just bang it in there, and that is pretty much it. As you can see, our code there, a lot simpler and a lot easier to read. Let's have a look at that, make sure that it works fine. And we end up with 663 rows. There's our customer name, total order value and average order value. Data looks kind of familiar, so we have achieved a subselect but as a common table expression instead. Let's have a look at another example that I've got for you here. So this is another bit of code that was taken from the previous part, pretty much, and again all we need to do to start off with is use the command with. We're going to call this one stock as, and then simply cut that out there, paste it in there, and then take stock and paste it like that, and that is it. That is how easy it is to build a CTE from a subselect. And there you go, very similar data to the subselect itself. 227 rows. I'll Control Z, back to our original, get rid of that quickly, execute that, 227 rows. So it's pretty much the same thing, but just easier to write and a lot easier to read when you're looking at the code itself. There's our table, and there's the table we created on the fly using our CTE. Pretty straightforward stuff. Again, that's kind of my preference, and you might even find that writing a CTE and then bringing it in to your select statement may perform more efficiently than using a subselect within your joins, etc., etc. So play around with the two options if you're feeling brave, and check which works most efficient when you start writing your code. Brilliant stuff. Now, CTEs can also be extremely flexible. You can write one after the other, as you've seen there, because as we know, the CTE is consumed within your select statement below. So the stock table that you generated here with the CTE, once the query terminates, that's it. Once the select statement finishes, that's it. That stock table disappears from SQL Server's memory. It's used here only once to run off the select statement, and then it's gone. So what happens if you need to create several CTEs, or if you wanted to have several subselects brought out of your select statement into CTEs? Well, we can do that quite easily. Start off with the usual width, bring in your first CTE, again with the brackets, make sure you put the command as in there, and as you can see, we form our first CTE here, and we can run it off, execute it, and we get our results there. Pretty straightforward. If we want to add then a second CTE to use in our select statement below, all we simply do is put a comma. Then we put in the next pseudonym or name that we want our CTE. There's the as, here's your open and close brackets, and here is the next CTE code here written there. Let's execute that. As you can see, we're generating another table on the fly, 70,000 rows. So we've created 2 CTEs ready to be used by our select statement below. However, we can also build another CTE and use the values within one of the CTEs above as well. So as you can see, we'll put a comma in here. Orders over 50, I've called it, as open brackets, close brackets, and here is my code itself. I'm basically just wanting all the order IDs where the order totals from our order total CTE, where the total order quantity is greater than 50. So if we execute that, so I want to pull anything over 50. So this one, this one, this one, exclude that one, and that one, and that one, and that one, because they're less than 50. So it's kind of like a filter in a way. Obviously, I could have put the where clause in here, but I just wanted to show you that you can actually create another CTE and bring in values from a CTE above into that CTE. So here's our where clause, where the total order quantity, which is written there, is greater than 50. Now obviously we can't run this code off because it doesn't know what order totals is. That's because we haven't run this whole subselect off itself, this whole CTE. So if we wanted to see that value there, all we simply do is type in a select statement underneath. Very quickly, let's grab that and run the whole thing off. Now you have to run the whole thing off, all your CTEs with your select statement. And there you go, there's all our order IDs, which have got total order quantity from this CTE greater than 50. Pretty straightforward. And there you have it. So once we've done all our CTEs, we've built them up, we've got everything that we need to use, we then just simply bring them in to our select statement. Now here, as you can see, we're pulling order ID from orders, the order line ID and description from order lines, and we've also got invoices as well. We're bringing all of those in as I, so we've got the invoice ID and the invoice date. Right, then we're bringing in our CTEs. So order totals, we know that orders, we can inner join them because orders and order lines and our order totals, which are formed off our order lines as well up here, we know that we can inner join them all because there's no nulls, etc. That we have to have order lines for every order, pretty much. Therefore our order totals, we bring them in here and we get our total order quantity and our total order price. So that's our order totals that we calculated with the first CTE, brought in to our table, our select statement that we want to generate. Next, we then left join our invoices because we know that with some orders haven't been shipped yet, therefore we know we still want to bring that data in, and if it's been invoiced, then we bring that invoice data in. If not, then it'll just show up as null in that table. So any of the invoicing data will show null if there hasn't been any invoices for those orders. Next, we're bringing in the invoice totals from our second CTE here. And again, because it's coming from invoicing, we want to make sure it's left joined as opposed to inner joined, just in case any of our orders haven't been shipped yet. And that is pretty much it. What are we using our third and final CTE for? Well, we're going to put in a where clause where the order ID is in, and as you can see here, we're using a subquery. We're selecting the order ID from the orders over 50 CTE here. We of course could have just said and order ID in select order ID from order lines where some is etc, etc. We could have done this another way, but it's quite easy to just build a very quick CTE to pull back a very small amount of data and just say in and then brackets, do a subquery, select order ID from our third CTE. Now don't worry too much about the logic here, the command in. Again, we'll be covering that on a later episode. Suffice to say, we just want all the order IDs that are in this already filtered CTE here. So let's have a look. Let's run off the entire block of code. And there you have it. So all of these up to the invoice date, these are all the single line values that we're pulling from these first rows here, from our tables that we're joining, and then we're bringing our CTEs. Here's the orders, and here is your invoicing. So there's quite a lot going on, but we split out the CTEs above and then made it a lot easier to then bring them in to our select statement. So while there was a lot going on there, as you can see, the logic is a lot easier to follow with your CTE stripped out, and then you just simply build your select statement from there. Right then, that's CTEs pretty much covered for you there. So similar to your sub-selects, however, you build them up first and then you do your select statement afterwards. Let's then put your skills to the test with another practical example for you to tackle. Right then, the scenario is that the marketing team are trying to put together a campaign to pump up sales to our least popular customers, but need to know which ones those are. So they've asked you to check out the customer invoicing in the system for 2016 and provide them with the customers who have total invoiced amounts less than the average. You'll need to construct your query in stages as follow. So, first step is to create a query of invoice line transactions for 2016 and sum them up to get the invoice ID. So we're looking at potentially the invoicing tables, sales invoice and invoice lines, and sum the extended prices to get a total transaction amount per invoice ID. So that should be relatively straightforward. So create a query based on that first of all, and there's a filter to throw in there as well for the year. The last edited when column is 2016. Once you've done that and you've checked that it works fine, turn in the data, okay, then turn it into a CTE and build a select statement to bring back the following columns. So we're wanting the customer name, I'm sure you all know where that comes from, the invoice ID, and the total transaction amount for each customer. For each customer, for each invoice ID. So basically, we've got the invoice IDs there. We need to now somehow link them to the customers, and I'll leave that to you to do in your query. Now, there is a where clause. If you want to tackle this, don't worry too much if it's a little bit confusing and you don't quite have the logic yet. Main thing is to follow step 1 and 2 and build your CTEs. And if you're keen, if you think you can work out the logic for your where clause here, what we're saying is we want all the transaction amounts, total transaction amounts that we're calculating here, that are below or less than the average total transaction amount. Now, the thing with this little filter that we're going to add on there is that you can use the same CTE more than once in your select statement. So obviously you build your CTE to begin with, and then you bring it in, joining with other tables to give you this information here, and you're then bringing back the invoice ID and the total transaction amount from your CTE. But you can then, in your where clause, also reference that CTE. So you can do an average, probably based in a subquery, but I'll leave that for you to figure out. Right then, the answer will be in the next video, and as I mentioned, don't worry too much if you can't figure out this little filter. Main thing is to get step 1 and step 2 done and linking up your CTE with the customer name. So give that a try and we'll go through it on the next video. Everyone, until then, I hope you all have a fantastic day.